Okay, so for this video I'm just going to do a few examples just to make sure that people understand the way to do differentiating. And I've tried to make some examples up which have some little complexities that make it more difficult. So let's look at the first one, which is actually an easy one. The first one, we've just got y equals 6x squared minus 9x plus 2. So if we're differentiating this, the first thing we're basically going to do is to look at it and think, is it y and x? Well, it is, so therefore we're going to start off with dy by dx equals. So then we look at the first term, and the rule is multiply the power by the number in front. So 2 times 6 is going to give us 12. And we reduce the power by 1, so that's x to the 1. Well, normally x to the 1 we would just write as x, so I'll leave that as 12x. If we look at the next term, it's minus 9x. Hopefully you've got the hang of this one. All you need to do, if it's just an x term, you can just remove the x. It does actually follow the same rules as before, so you could take the power and multiply by the number in front and reduce the power by 1. It does work, but just remember the rule. If it's something x, it just becomes something. So that becomes minus 9. And the last thing, the 2, that is again worked exactly the same way. The power of x this time would be 0. And when you multiply 0 by anything, you just get 0. You probably remember that if it's just a number on its own, it disappears. So the answer to that first one is just 12x minus 9. dy by dx equals 12x minus 9. Right, let's do the next question. A little bit different. First of all, it's not y, it's v, and it's v and t. So the first thing we need to do is to make it not dy by dx, but it is going to be dv by dt. So I'm going to just type that in there. Now it comes up with y and x, so I'm going to change this to v and t. So dv by dt equals. Then we look at the first term. Now it's got a fraction in there, but really it doesn't make any difference. You just multiply the power of the variable, so 2 times 2/5, and 2 times 2/5 is 4/5. So I can just write in here 4/5. And then we've got to reduce the power by 1, so instead of being t squared, it's just going to become t. That's the first term done. The second term, it's 7 over 4t. Now 7 over 4t is just a bit like 9x really. We just need to get rid of the variable. It just becomes plus 7 over 4. So I'll just put that in. And then finally, the last term is just a number. It's minus 2/3, and minus 2/3 just is a number, so it just disappears. So the answer to question 2 is just dv by dt equals 4/5 t plus 7 over 4. Right, question 3. Again, a little bit harder. First of all, you've got some negative powers in there, fractions again, so it's not looking like the most easiest question. But the first thing we need to do is it y and x? Yes, it is. So we're basically going to do dy by dx equals. Then we look at the first term. Now, I've told you here, if you've got a fraction, you could separate the fraction from the variable. So you could write this as 2 over 7 x to the minus 3. And if you do that, then the minus 3, you need to multiply by 2 over 7, which is going to give you minus 6 over 7. Okay, and then we've got to reduce the power by 1. Now this is sometimes people have made mistakes on this. When you're reducing the power of minus 3 by 1, it doesn't become minus 2. When you reduce minus 3 by 1, it becomes minus 4. So that just becomes x to the minus 4. That's the first term done. All right, now we need to look at the second term. Now the second term, again, we could separate the fraction, so we could make it a quarter x to the minus 1. Whenever you get a negative fraction, with negative power, sorry, it will always change the sign of the term. So we've got to multiply that power, which is minus 1, and we're timesing it by the quarter, so we're going to get minus a quarter. So it's minus a quarter something. and then we've got to reduce the power by 1. So it's minus 1 already. When you reduce it by 1, it becomes minus 2. So that is x to the minus 2. Okay, I don't know how easy that is to understand. That's that question done. You may want to just look back on that and think, how did that question become that answer? And just review it again. Okay, let's look at question 4. So question 4, it's a bit difficult, this one, because it's got the variables are on the bottom. The t is on the bottom. Anyway, first of all, is it y and x? No, it's not. So the first thing we're going to have to do is to make sure that we put in ds by dt rather than dy by dx. So that's ds by dt equals. Actually, even before this, I'm going to just rewrite the question. I think it's quite important that when you've got variables on the bottom, we are going to put them on the top before we differentiate it. So I'm going to just go back a little step. So that's why I've gone into that space there. And I'm going to rewrite the question. So if you rewrite the question, it becomes s equals, now we're moving the variable from the bottom to the top, and that changes the sign of the power. So instead of being 4 over 5t squared, it's going to become 4t, sorry, over, the 5 is going to stay where it is, the 4 is going to stay where it is, but the t squared is going to go onto the top, but it's going to become a negative power. So it's t to the minus 2, like that. Okay, and that's how you rewrite that first term. I'm also going to rewrite the second term. So it's just going to be minus, and I'm going to leave it as 6, move the t to the top, and becomes a negative power. So it's 6t to the minus 1. Okay, now that is the same question. It looks very different, but it is the same question as the original question. Now we're going to go back to differentiating it. So we look at the first term. We're going to multiply the power, the minus 2 times 4 over 5, which is going to become minus 8 over 5. So minus 8 over 5. We've also got to reduce the power of t by 1. So reducing that, t to the minus 2 becomes t to the minus 3. The second term, it's a negative power again. So we're going to multiply the minus 1 by the minus 6 is going to become a plus 6. And also we've got to reduce the power by 1, so it becomes t to the minus 2. Quite a hard question, that one. Again, you may just want to recap the stages. When you've got a variable on the bottom of a fraction, you need to move it to the top before you can differentiate it. Okay, the last question. This is another one, quite very, very difficult one. You're not going to get anything like as hard as this actually in the assignment, but it's the rules that you need to get used to, and get used to indices and fractions, so you get good at calculus. So first of all, we are going to rewrite this because we've got an x on the bottom, so we're definitely going to rewrite this. So I'm going to start off with y equals, now the root of x, you should know this when we did indices, the root of x is the same as x to the power of a half. So I'm going to write x to the power of a half. Even that takes a bit of time to do, so I'm just going to write that in there, over 2. That is the same as that original question there. And then we look at the second term, and again I'm going to move the x to the half on the bottom. I'm going to move the x to the half onto the top. So the numbers stay the same, it's 2 and 3. And the x is now x to the minus a half because we moved it to the top. I don't know how easy that is to make sense. Will make sense to you. So it should be like that. Okay. So now we can actually do the question. That's rewriting the question by changing the square roots to powers of halves and then anything on the bottom we've moved it to the top and changed the sign of the power. Okay, now we need to actually differentiate it, and it's y and x, so we're going to write dy by dx equals. So let's look at the first term. We're going to multiply the power of a half times the number in front. Now the number in front really here is a half, so half times a half is a quarter, which is that. And then we've got to reduce the power by 1. Now, reducing the power by 1, it's already a half. If you take 1 away from a half, you actually get minus a half. So actually, you get that. And that's how you differentiate the first one. Then we've got to differentiate the second one. Now, it's a minus term, but we've got a minus power. So when we multiply the two together, it's definitely going to be a plus. We've got 2/3, and we're timesing 2/3 by the half, by the minus a half. So we're going to get 2/6, which is the same as 1/3. So I'm going to write 1/3 in there. Okay, and then we've got minus a half, x to the power of minus a half. So we've got to take 1 away from that. Taking a 1 away from minus a half is minus 1.5, which is minus 3/2. So it becomes x to the power of minus 3/2, like that. And that's it. Now those are very difficult examples. I would say basically you should be able to understand particularly the first three. Number 4 is getting quite tricky, and it's probably harder than you're going to get in an assignment. Number 5 is very difficult, but they are all based on the rules of fractions and indices, and obviously this rule of how you differentiate something. You take the power, multiply by the number in front, and reduce the power by 1. Okay, I hope that's clear. I hope that makes some kind of sense.